Hello everyone, my name is Karan Mashru. Welcome to this video. In this video, we are going to look at the solution of the problem, that is it a tree? So first of all, let us start by understanding the question. What does question say? You are given an undirected graph of n nodes and m edges. So we have a graph which is undirected, so the edges do not have a direction and it has n nodes and m edges. Return 1 if the graph is a tree, else return 0. The input graph can have self loops and multiple edges. Okay, so the graph can have self loops and multiple edges. So here a basic example is given. The output is 1. Here the output is 0. I'll explain it to you while understanding the question in depth. You don't need to read input or print anything. Your task is to complete the function tree, which takes the integer n, the number of nodes in the input graph, and the edges representing the graph as input parameters, and returns 1 if the graph is a tree, else 0. The expected time complexity is big O of n plus m, and the expected auxiliary space is big O of n. So now if we try to solve this problem, then see, basically we are given a graph which has basically n number of nodes and m number of edges. Okay, and we need to tell whether this graph represents a tree or not. Okay, if yes, we need to return 1, otherwise we need to return 0. Now when can we say when a graph is a tree or not? First, if the number of edges in graph is n minus 1. So if the number of nodes is n, and if the number of edges is n minus 1, and if the graph is connected, then we can say it is a tree. Okay, so for example, if there are n number of nodes in the graph, then the number of edges must be n minus 1. Okay, and this graph must be connected. If these two things are satisfied, then we can say it is a tree. Okay, so basically in tree we cannot have self loops, we cannot have multiple edges, also there cannot be a cycle, right? And between any two nodes there will be a single shortest path, etc. So in order to satisfy the condition, if there are n nodes in the graph, there must be n minus 1 edges and the graph must be connected. Now what is the meaning of connected graph? Connected graph means there must be a path between any two pair of vertices. Okay, so for example, if this is my graph, okay, let's say this is 1, 2, 3, 4, 5, 6 and 7. Okay, so n is equals to 7. Now this is a connected graph. Yes, why? Because there is a path between each and every pair of vertices. You take any two pair, you will find a path between them. So this is a connected graph. Okay, now there are no self loops or multiple edges. So if you want to cross verify, there will be n minus 1 edges only. That's why this is a tree. For example, here there are how many edges? 1, 2, 3, 4, 5 and 6. So the number of edges are how much? 6, which is nothing but n minus 1. Okay, so here the number of edges are n minus 1. It is connected, so it is a tree. Now let's look at the given two examples. So for the first example, we have n equals to 4 and m equals to 3, and the edges in the question are given in the form of a 2D matrix. Okay, where each row will have two columns, the first column representing one node and the second column representing another node. So basically in each row there will be two columns, and the nodes in this column represent an edge between them. So here there are 4 nodes from 0 to n minus 0 to 3. Okay, so 0th node, first node, second node and third node. First edge is between 0 and 1, second edge is between 1 and 2. Sorry, first edge is between 0 and 1, second is between 1 and 2, third is between 1 and 3. So this is a connected graph. Yes, because from any vertex you can go to any other vertex and there are n minus 1 edges. So this is a tree, right? So we will return true. If I look at this example, there are 4 nodes. So this is 0, 1, 2 and 3. There is a edge from 0 to 1, there is a edge from 1 to 2, and there is a edge from 2 to 0. Now you see here the number of edges are n minus 1, but this is not connected, because from 3 you cannot reach to 0, and hence there is also a cycle. In tree there should not be cycle. You can see there is a cycle being formed. So this is not a graph and not a tree, and we will return 0. So basically what we need to check is, we are given n nodes and m edges. Okay, so first of all, m must be equal to n minus 1 and the graph must be connected. Now how will we check whether the graph is connected or not? We will run a DFS starting from index 0. If in one DFS we can visit all the other nodes, it means the graph is connected, right? Because from 0, if you can visit all the other nodes and the edges are undirected, it means every pair of vertices is connected, right? There is a path between every pair of vertices. So we will run a DFS starting from index 0 and node number 0, and if you can visit all the nodes, it is connected. and the number of edges must be equal to n minus 1. If both the conditions are satisfied, we will return 1, otherwise we will return 0. Now let's look at its actual implementation. So if we look at the actual implementation, so I have been given a 2D vector adjacency list, but actually this is representing the edges, okay, in terms of m cross 2 size. So there are m number of rows representing the m edges, and each row have 2 columns, okay, representing the 2 nodes of a particular edge. So first of all, I have taken one vector adjacency list 1, in which I will actually store the adjacency list. Why I need adjacency list? Because during traversal of the graph, I will require it, okay. I can't just have all the edges in one array, okay. First condition is if m is not equal to n minus 1, directly return 0. If m is equal to n minus 1, then another condition we need to check is whether the graph is connected or not. So I have taken one count variable, which will, whenever I will visit a node, I will increment the count. So in one DFS, I will check whether my count is equal to n or not. That's why I've taken count variable. Then there is one index I, and then there is a visited array. Whenever I will visit a node, I will mark it as visited, okay, which we do in DFS. First of all, I have marked all the visited as false. And then for all the edges, first of all, I have made the adjacency list. So ith edge is between which node? Adjacency list of I0 and adjacency list of I1, right? This is the ADJ 2D matrix. So what I have done is I have created the adjacency list with the help of that. So if there is the edge between this node and this node, then in the adjacency list of this node, I must push back this node, and in the adjacency list of this node, I must push back this node. Okay, so this is how I created the adjacency list. Then I have called a DFS starting with vertex 0. I have passed the visited array. I have passed the adjacency list which I have formed, and I have passed the count array. Also, this count will count variable. This count will be passed with the help of reference, okay, not value. After coming out of the DFS, if count is equals to n, it means m is equals to n minus 1, and this graph is connected, so it is a tree. I will return 1, otherwise I will return 0. Now let's look at the DFS code. So whenever I visit a particular node, I will first of all increment the count. I will mark visited as 2. I will take one more variable, and I will take this m as the adjacency list of I. So for all the adjacent elements of I, if they are not visited before, I will call a DFS. That is how we run a DFS. Okay. And after coming out, if the count is equals to n, then we will return 1. Otherwise, we will return 0. What would be the time complexity here? It would be big O of n plus m, because we are traversing all the nodes and edges once, which is the typical time complexity of a DFS. And what would be the auxiliary space? The auxiliary space here will be big O of n, because we are using this visited array which is of size n, right? So that will take this much space. Also, we will also store the adjacency list, right? So actually, because we are taking another arrays to store the adjacency list, right? So actually it should be n plus e, right? Because we are storing adjacency list once again. Okay, so the auxiliary space will be this and the time complexity will be this. Now let's submit this code. Let's submit it. Okay, so we have solved this question successfully. I hope you have understood the solution completely. Thank you.